For centuries, humanity has looked up at the stars wondering what lies beyond our cosmic backyard and whether we are truly alone in the universe. Telescopes gave us distant glimpses, but they were never enough, so we built machines brave enough to leave home and travel into the unknown. Among all of them, two stand above the rest: Voyager 1 and Voyager 2. After more than 4 decades drifting through space, one of these legendary probes went silent for months. And when Voyager 2 finally called back home, it was not just a technical check-in. It was a message from a place no human-made object was ever meant to reach. Tonight, we are going to explore where Voyager 2 really is, what it detected after turning back toward Earth, and why its data is forcing scientists to rethink what exists beyond the edge of our solar system. Voyager 2 was never supposed to still be talking to us. Approved in the early 1970s, originally known as Mariner Jupiter-Saturn, it was built for a mission measured in years, not decades. Yet here it is, more than 40 years later, still operating far beyond every expectation NASA ever had. Launched in August 1977, Voyager 2 took advantage of a rare planetary alignment, using gravitational assists like a cosmic slingshot to visit the giant planets. This single probe gave us our first close looks at Jupiter, Saturn, Uranus, and Neptune, revealing storms larger than Earth, active volcanism on distant moons, and planetary systems far more complex than anyone imagined. But the real surprise came later, when the mission quietly transformed from planetary exploration into something far more profound. Voyager 2 did not stop at the edge of the solar system. It kept going. There is no sign in space that says, "You are leaving the solar system now." Instead, there is an invisible boundary called the heliosphere, a vast bubble created by particles streaming outward from the sun. For decades, Voyager 2 traveled inside this protective shell, shielded from the harsher environment beyond. Then, in November 2018, everything changed. The probe detected a sudden and dramatic drop in solar wind particles, combined with a sharp increase in high-energy cosmic rays coming from outside our system. At the same time, it measured a stronger interstellar magnetic field pressing inward. These signals meant only one thing: Voyager 2 had crossed into interstellar space. This was not empty darkness. It was a violent environment filled with radiation, charged particles, and forces powerful enough to remind us just how fragile our solar bubble really is. Communicating with Voyager 2 is like listening for a whisper from across an ocean of stars. Its transmitter is weaker than a refrigerator light bulb, and by the time its signal reaches Earth, it is unimaginably faint. Yet after 7 months of silence, caused not by failure but by maintenance on Earth's deep space antennas, Voyager 2 responded. It confirmed that it was alive, that it had received new commands, and that it was still functioning in interstellar space. That moment mattered more than it seemed. It proved that a machine built with 1970s technology, running on tape recorders and computers thousands of times weaker than a modern smartphone, could survive in one of the most hostile environments we have ever measured. But more importantly, it confirmed that Voyager 2 was still sending us real data from beyond the sun's influence, data about a region we cannot visit ourselves. What Voyager 2 has shown us is unsettling in its simplicity. Outside the heliosphere, cosmic radiation is intense, far more powerful than what we experience inside our solar system. The sun's protective bubble shields every planet, every spacecraft, and every living thing here from a constant storm of energetic particles coming from the galaxy itself. Voyager 2's measurements confirm that interstellar space is not calm or empty. It is active, aggressive, and unforgiving. This has enormous implications. It tells us that long-term human travel beyond the solar system will face dangers we are only beginning to understand. It also reminds us how rare and delicate our cosmic shelter truly is. Voyager 2 is no longer just an explorer. It is a warning beacon, quietly transmitting the reality of what waits beyond the edge of our sun's protection. One of the most unsettling aspects of Voyager 2's story is not where it is, but how it is still functioning at all. The onboard computers were designed in the 1970s, with less memory than a single modern image file and processing power so limited that today's smartphones outperform them by thousands of times. Yet these machines continue to operate flawlessly in interstellar space. Data is still being recorded on magnetic tape, a technology so old that no physical backups exist on Earth anymore. And somehow, after decades of radiation exposure, extreme cold, and complete isolation, the system still works. This raises an uncomfortable realization. Voyager 2 is not just a probe exploring space, it is a proof that even the most primitive human technology can endure environments we once believed were instantly lethal. If something built that long ago can survive out there, then interstellar space may be harsher than expected, but not uninhabitable for machines, and perhaps not entirely unreachable for humanity. Voyager 2 carries something no other spacecraft does. A golden record, etched with sounds, images, music, and greetings from Earth, created for one purpose only, to be found. This is not science equipment. It is a message in a bottle thrown into a cosmic ocean. And as Voyager 2 moves deeper into interstellar space, that record becomes more symbolic with every passing year. Communication will not last forever. One by one, instruments are being shut down to conserve power, and eventually, the radio signal will fade completely. When that happens, Voyager 2 will not stop traveling. It will continue silently, carrying Earth's voice into regions of the galaxy we cannot see. The warning here is subtle but powerful. Once contact is lost, Voyager 2 becomes a permanent artifact of human existence, drifting among the stars without guidance, without updates, and without witnesses. Voyager 2's data has revealed something we rarely think about while living under a calm blue sky. The heliosphere is not just a boundary, it is a shield. Inside it, radiation levels are manageable. Outside it, the galaxy reveals its true nature. Voyager 2 recorded a sharp increase in galactic cosmic rays immediately after crossing this invisible wall, along with a stronger magnetic field pressing inward. This tells us that our solar system is wrapped in a fragile bubble, constantly holding back a storm of energetic particles capable of damaging electronics, DNA, and biological systems. The warning here is not dramatic, but it is profound. Leaving the solar system is not just about distance. It is about survival in an environment that actively works against anything unprotected. What makes Voyager 2's discoveries so powerful is that they are not just about today. They are about every future mission that dares to go farther. The probe is mapping a region humanity has never touched, measuring conditions we must one day face if interstellar travel becomes more than a dream. Its data is already reshaping how scientists think about spacecraft shielding, long-duration missions, and the limits of human exploration. Voyager 2 did not turn back physically, but its signal did. And what it sent us was not comfort, it was clarity. The universe beyond our sun's influence is real, active, and unforgiving, and any civilization that wishes to step into it must be prepared. By this point, the act of communicating with Voyager 2 has become a scientific feat in itself. The probe transmits with a power comparable to a small household light bulb, and by the time that signal reaches Earth, it is weaker than anything we encounter in everyday technology. NASA's Deep Space Network must combine some of the largest radio antennas on the planet just to catch that whisper from the void. What makes this even more remarkable is the distance involved. Voyager 2 is so far away that every command takes hours to arrive, and every response is already history by the time we receive it. This delay forces engineers to think differently, to anticipate problems long before they occur. In a way, Voyager 2 is teaching humanity how to communicate across truly interstellar distances, revealing how fragile and precious a single bit of information becomes once you leave the comfort of the solar system. The data Voyager 2 continues to send paints a clear picture of the dangers lurking beyond the heliosphere. Galactic cosmic rays are not a minor increase. They are a constant bombardment of high-energy particles capable of penetrating shielding and disrupting electronics. Inside the solar system, the sun acts as a guardian, deflecting and weakening much of this radiation. Outside, that protection vanishes. Voyager 2's instruments show that interstellar space is not just cold and dark, it is actively hostile. This has serious implications for any future attempt to send humans beyond our solar neighborhood. The warning here is subtle but unavoidable. Technology alone is not enough. survival beyond the heliosphere will require a fundamental rethink of how we protect both machines and living beings from a universe that does not care whether we are ready or not. As instruments are slowly powered down to conserve energy, Voyager 2 is transitioning into something new. It is no longer just a scientific probe, it is becoming a time capsule. Every subsystem that shuts off marks the end of an era, yet the spacecraft itself continues forward, unchanged in purpose but altered in capability. Long after contact is lost, Voyager 2 will still exist, drifting silently between stars, carrying with it a snapshot of humanity from the late 20th century. Its hardware, its golden record, and even its outdated technology will one day represent a fossil of our civilization. This raises a quiet but profound thought. Voyager 2 may outlive every structure we have built on Earth, becoming one of the longest-lasting artifacts humanity will ever create. Eventually, the moment will come when Voyager 2 can no longer respond. Its power will drop too low, its transmitter will fall silent, and Earth will listen to nothing but static. But silence does not mean the mission ends. It simply means the conversation does. Voyager 2 will continue on its trajectory, passing near distant stars tens of thousands of years from now, long after current civilizations are gone. This forces us to confront a strange idea. We often think of exploration as something that ends when communication is lost. But in reality, Voyager 2's journey will continue long after we stop paying attention. The warning is not just about space, it is about time. Our reach can extend far beyond our lifespan, and what we send out into the universe may persist long after we are no longer here to explain it. When people say Voyager 2 turned back, they are not talking about a physical reversal in space, but something far more symbolic and unsettling. What turned back was its attention, its signal, its data flow toward Earth after months of silence. For a probe that has been moving steadily away from us since 1977, that renewed communication felt like a voice coming back from beyond a frontier we barely understand. The signal carried confirmation that Voyager 2 was still alive, still oriented correctly, still able to listen and respond, even after crossing into interstellar space. That moment reframed the mission. Voyager 2 was no longer just moving forward into the unknown. It was now actively reporting from it, sending back measurements that directly challenge our assumptions about what lies beyond the sun's reach. One of the most important realizations coming from Voyager 2's data is how wrong our intuition about interstellar space really is. We tend to imagine it as a vast, silent vacuum, but the instruments tell a different story. Voyager 2 detected a dense environment of energetic particles, strong magnetic fields, and constant radiation pressure. This is not a passive backdrop. It is an active medium that shapes anything traveling through it. In a way, the probe revealed that the heliosphere is like a calm harbor, and interstellar space is the open ocean beyond it, filled with invisible storms. This realization alone is enough to unsettle scientists, because it means every object, natural or artificial, is being continuously sculpted by forces we rarely consider when looking up at the night sky. What makes Voyager 2's discoveries even more powerful is that they did not happen in isolation. Voyager 1 crossed into interstellar space years earlier and reported similar changes, but with slightly different details. Voyager 2 confirmed those findings from a different trajectory, at a different angle, and with a different set of instruments. Together, the two probes removed any remaining doubt. The boundary of our solar system is real, and what lies beyond it is measurably harsher. The increase in galactic cosmic rays and the change in magnetic field strength are not anomalies or glitches. They are consistent features of interstellar space. When two independent messengers tell the same story from different paths, the warning becomes impossible to ignore. The most important thing to understand is that Voyager 2's message is not a warning in the cinematic sense. There is no imminent danger approaching Earth. Instead, this is a long-term warning, aimed at the future of exploration itself. Voyager 2 is telling us that leaving the solar system is not just a matter of building faster rockets or smarter computers. It is about facing an environment fundamentally different from anything humanity has ever operated in. Radiation, magnetic forces, and particle storms will define the rules. Any future mission, whether robotic or human, will have to be designed with these realities in mind. Voyager 2 is not closing the door on interstellar travel. It is quietly pointing out how heavy that door really is. One of the quiet but deeply unsettling implications of Voyager 2's data is what it reveals about human vulnerability. Inside the heliosphere, life and technology exist under a kind of cosmic umbrella, protected from the worst radiation the galaxy can throw at us. Outside that boundary, Voyager 2 shows there is no such mercy. High-energy particles move freely, magnetic turbulence is constant, and shielding that works near Earth becomes far less effective. This forces scientists to confront a difficult truth. Any future spacecraft carrying humans beyond the solar system will need protection far beyond what we currently understand. Voyager 2 is exposing the limits of our assumptions, reminding us that the universe beyond our sun is not designed with human survival in mind. Another insight emerging from Voyager 2's measurements is that interstellar space actively reshapes anything moving through it. Radiation does not simply pass through objects, it alters them over time. Electronics degrade, materials weaken, and surfaces are slowly modified by constant particle impacts. Voyager 2 itself is a living example of this process, its continued operation almost defiant given the conditions it endures. Scientists now believe that interstellar space is less like an empty highway and more like a grinding current, slowly wearing down everything that enters it. This changes how we think about long-term exploration. The challenge is not just reaching distant stars, but surviving the journey through the space between them. Voyager 2's discoveries also force us to think in terms of time, not urgency. The data it sends today will shape missions that may not launch for decades, or even centuries. Its measurements are not warnings for the present, but instructions for the future. They tell future engineers where shielding must improve, where instruments must adapt, and where our understanding is still dangerously incomplete. In that sense, Voyager 2 is communicating not just with today's scientists, but with generations yet to come. It is a reminder that some messages are not meant to provoke fear, but patience and preparation. As Voyager 2 continues its journey outward, its role becomes almost philosophical. It is a small, fragile machine carrying the weight of human curiosity into a place where curiosity alone is not enough. Every transmission is weaker than the last, every response harder to detect, yet each one carries immense value. Voyager 2 is showing us that the universe does not announce its dangers loudly. It whispers them slowly, through data points and long-term trends, through a probe drifting alone in the dark. And those whispers, if we choose to listen, may determine how far humanity can truly go. When you put all the pieces together, Voyager 2 stops being just a spacecraft and becomes something else entirely. It becomes a messenger, not from another civilization, not from a distant star, but from the edge of our own protection. What it sent back was not a single shocking image or a dramatic signal, but a slow, undeniable truth built from years of data. Beyond the heliosphere, the universe is not empty, not calm, and not forgiving. It is filled with radiation, magnetic turbulence, and energetic particles that relentlessly shape everything that enters that space. Voyager 2 did not turn back physically, but its signal did, and what it carried was a warning about limits. The limit of our technology, the limit of our protection, and the limit of how casually we talk about becoming an interstellar species. This probe, built with computers weaker than a smartphone and powered by fading nuclear batteries, has survived longer and traveled farther than anyone imagined. Yet even it is slowly being worn down by the environment it revealed to us. That contrast matters. It tells us that exploration beyond our solar system is possible, but it is not simple, not safe, and not something we can rush into without understanding the cost. Think about it this way. For all of human history, we have lived inside a bubble we did not even know existed. Voyager 2 was the first to step outside and describe what it feels like out there, and what it found forces us to grow up as a spacefaring civilization. The stars are reachable, but the space between them demands respect. Voyager 2 is still out there, drifting farther away, its signal growing weaker, its journey continuing long after we stop listening. And that may be its final lesson. The universe does not warn us loudly. It gives us time, data, and one chance to learn. If you want to keep following this story, and others like it, make sure you're subscribed, because the most important discoveries often happen far from the spotlight. Share your thoughts in the comments, because this question affects the future of exploration itself. And remember, every time we look toward the stars, Voyager 2 is already there, quietly reminding us how vast, powerful, and unforgiving the universe truly is.